This essay is about Johannes Kepler, um, who actually died on November 15th, um, nearly 500 years ago. Um, and he was a kind of an astrophysicist, and he came up with two very critically and very important laws um, nearly half a millennium ago. And the first law is that if you have a star and it has planets rotating around that star, the star is never in the center of um, that journey of the planet. In other words, the planet goes on an ellipse around the sun or the star, but the star is off center. So it's not like what they thought years before that, is that the sun or the star is at the very center of the solar system, and all the stars go around in circles. They really go around in ellipses, and because they go around in ellipses, the um, the when the sun or when the planet is approaching the gravitational pull of the star in proximity, it's getting closer and closer to the star, it goes faster and faster. And when it goes past the star, it starts to slow down until it comes back and orbits back into the gravitational field. And it does this so that the journey of the planet is not at the same speed. Um, that's a history lesson. Uh, in 2009, NASA launched Kepler. Um, really, it was a huge telescope. And what they did was to go to a part of the Milky Way, and that Kepler spaceship or craft is concentrating on one small section of the Milky Way, which is, and the Milky Way is just one small galaxy in the millions and millions of galaxies out there. So it is just looking at a little fraction, you know, very small amount of the total universe. And what they're trying to find is life, some form of life beyond the Earth. And he is, or the telescope is spending a lot of time researching the what are called exoplanets, planets that go around a star that are outside of our galaxy or outside of our solar system. And scientists have determined that there is something called the Goldilocks zone, and the Goldilocks zone is when the planet is a certain size. It can't be too large or too small, but just the right size. Then that planet is called in the Goldilocks zone, where it's not going to be too much gravity, so that whatever life forms that exist on it, it can't get off the ground, and it won't be too light, so that the planet just doesn't have any kind of form of life, substantive life on it. And it's just because a planet is in the Goldilocks zone does not mean that there's life in that zone, but that's where life could only exist, at least as life as we know it could exist. So Kepler in the past was a genius, and NASA is a genius now, working with this space telescope to try to find life forms. Away from us. And it's interesting that they have come up with about 23 or 2,400 exoplanets that they think that that some form of life could exist. So it's a, you know, I've said this before. When I was in college, in grad school and post-grad school, I took one science class, and that was geology. And didn't take chemistry, didn't take physics, didn't take anything, any other science class. And yet, because I haven't taken a lot of science, it intrigues me to learn more, even at my age, about the various sciences. And one of the people who I really admire was Carl Sagan. And in fact, I wrote to Sagan a long time ago about something that he had done in one of the Cosmos series. And I said, you know, I need to know some data. And he said, what you're requesting, you said exactly what we would have done. So I still have that letter from Carl Sagan, which I treasure. So I hope you enjoy this essay, and thanks for your time. Take care.